So today we're going to talk about how do we determine the exact trigonometric values for special angles. So the special angles that we've been talking about is 30, 45, and 60. And we know those trig values, but we're going to talk about those trig values in the unit circle if it's in the second quadrant, third quadrant, or the fourth quadrant. So I know we talked about reference angle, and reference angle is important, and I want to make sure that there's no misconception with the reference angle. So reference angle is formed by dropping a perpendicular from the terminal ray of a standard position of an angle to the x-axis. So I think I modeled it from quadrant 1, 2, 3, and 4 separately, but here's a different picture where you can see that the triangle, when you draw the reference angle, it's always bounded, one of the legs are always bounded on the x-axis. So it's going to look like this picture, like a bow tie. So if it's in the first quadrant, it's going to look like the green triangle. If it's in the second quadrant, it's going to look like the yellow one. If it's in the third, it's going to look like the red one. If it's in the fourth, it's going to look like the purple one. Okay, so this is a good diagram to see that reference angle should look like this. Now, we didn't look at the tangent too much in detail, but the tangent ratio, you guys know that is TOA, so it's opposite of adjacent. So from the previous lesson, we know that cosine is the x-coordinate, and the sine is the y-coordinate, but we didn't talk about tangent too much. But tangent is opposite over adjacent. If we use the y-coordinate and the x-coordinate as opposite over adjacent, it actually derives to sine over cosine. So tangent of theta is equal to sine over cosine. And it actually works out if you do opposite over adjacent, you get 1. We know that tangent of 45 is 1. If we actually put the ratio of sine of 45 and cosine of 45, it's going to give us 1. Okay, so that's important to remember. Now, looking at the signs, meaning positive or negative values in the trig functions, and we kind of talked about the unit circle, and I gave you guys increments of 30, 45, and 60 to practice. But we're going to just kind of put it all together. So if you notice in the first quadrant, all trig values are positive, just like all the coordinates that are positive over here. On the second quadrant, you know that the x value is going to be negative. So here, the x value being cosine, sine is going to be positive and cosine is going to be negative. So here, over here, all of them are positive. Here, only the sine is positive. On the third quadrant, you know that sine and cosine, so x and y, are both negative, but according to the tangent, we know that tangent is sine over cosine. So if we put negative divided by negative, you're going to get a positive. So here, the tangent is positive. In the fourth quadrant, of course, the cosine is positive and everything else here is going to be negative. So a mnemonic to remember the signs is all students take calculus. Of course, we're going counterclockwise. All the trig functions are positive. S stands for only sine is positive. T, only tangent is positive. And the fourth quadrant, only the cosine is positive. Okay, so all students take calculus is a cute mnemonic to remember the signs, either positive or negative, in the quadrants. So we're going to figure out how to find the exact value of tan of 3 pi over 4. So tan of 3 pi over 4, I already converted it to 135. So pi over 4 is 45. So it's 3 times 45. So it's 135 degrees. So now 135 degrees will lie in the quadrant 2. So instead of drawing the rotation, at this point you could just draw the triangle in the second quadrant. So it will look something like that. So over here, if we go 135 this way, it's going to, the reference angle is going to give us 45. So you guys can, or if you want to do 180 minus 135, you can do that too, but you know that it's going to be 45 degrees. I'm going to write it over in here. Now, if it's 45 degrees, remember tangent. So here is all student take calculus. Now you know that tangent is positive in the third, but it's in the second. So you know that this value is going to be a negative. So it's going to be negative value of tangent of 45 degrees. So now we can replace that with the reference angle. Now tan of 45 is going to be, we know that it's 1. So it's going to be negative 1. And then you can put that in the calculator and verify. And tan of 45 is 1, so it's going to be negative 1. Now this negative sign over here is actually what determines, because it's in the second quadrant, you know that tangent is negative in the second quadrant, so that's why the value here is negative. All right, so let's take a look at how we were going to find cosine of negative 120. Let's erase this. Now cosine of negative 120. So let's think about which quadrant it would be. So it's already in degrees, so we don't have to convert it. So, but because it's negative, it's going to go clockwise. So it's going to be in the third quadrant. So if we draw the reference angle in the third quadrant, the right angle is going to look like that. So since it's going to go this way, now the reference angle here is going to be how many more degrees that would be to become 180. So this is going to be 60 degrees. Probably should have draw it a little bit taller, because to draw it to scale, it's a little bit taller. So it's 60 degrees. My pen is not working that well again. 60 degrees. All right, so 60 degrees. Now, so let's take a look at it again. So this is all students take calculus. Now it's in the third quadrant. So tangent is positive in the third quadrant. Here we have cosine. Now this negative gives us the direction of the angle. So this negative tells us that's in the third quadrant. Now cosine in the third quadrant is negative. So here it's going to be negative. This is going to equal whatever this is. This is cosine of negative 120 is going to equal negative cosine, which means the value is going to be negative. Now, don't confuse the two negatives. This negative in here tells us the direction of the angle. The negative outside in front of the cosine function is the value. So you plug it in using the reference angle, which is 60. Now, this negative reappears here because we found the reference angle in the third quadrant that makes the value of cosine of 60 negative. Now, so cosine of 60 is 1/2, if you guys remember. So it's going to be negative 1/2. All right, so that's how you found the exact value of these trig functions in the unit circle. Now you guys try the other examples.